Right, so in this lecture, I'm gonna talk about fluid fluids. This is one type of fluids we have in Houdini, because also we have ocean effects, which is the next lecture. But today it's about particle fluid or fluid fluid. To start with this type of fluids, we need to create any object, let's say a sphere, and let's lift it a bit. And here we see that we have few buttons. First one is flip fluid. This flip fluid from object. This will convert the object into flip fluid. And alright, let's start from this. So I have a sphere, and it's selected, and now click on flip fluid button. And now we can see that Houdini converts geometry into liquid. And if I play the animation, it will fall down constantly, and that's all. Well, it happens because there is no ground, and we need to create one. In Rigid Bodies tab, we have ground plane, so let's create this one. Alright, so now if I play my animation, it will look like this. So the liquid is colliding and splashing. Okay, let's talk about default parameters for liquid in Houdini. So in the node editor, you can see that it creates a lot of new nodes, and here is our Autodop network. So let's dive inside. Hit L to layout, and here you can see that we have familiar nodes, which is for ground plane, merge, static solver, and here is the new types, which is flip fluid object and flip solver. Okay, let's select flip fluid object, and here one of the most important parameter is particle separation. So now you see that my particles okay, my particles is dark blue, and they're pretty huge, and the size, there is a huge separation between them. Well, if I change particle separation, let's say 0.2, I will get even bigger spheres, even more separation. But at the same time, it gives a lower resolution for liquid, the lower quality of simulation, and it also takes less memory, and of course calculates faster. So let's check this one. So now I have 0.2, and it plays really fast. But again, you see the huge splashes, and like this. This is not really nice. Alright, this is frame 53. Let's go back, and I change it back to 0.1. Here we can't see any changes, but if I switch back to frame 53, and wait a second for calculation, the splashes will be more detailed and sharper. Yeah. Okay. Preview this. Preview 0.2. So you see the calculation time is really much more faster. And this is difference between 0.1 and 0.2. So this is pretty obvious. Okay, and if I set it to 0.05, I will get really small spheres, and this will take much longer to calculate, and you need to have a really nice processor to do these calculations. So if I switch to 53 now, and it calculates faster when it's not playing the animation, but when you just set the frame, because it's not updating the viewport and it's not wasting resources on updating. So it's way faster. Okay, it's already half a minute, while the previous one was calculating in 7 seconds or something. So the simulation time increases not linearly, but I guess it's a geometrical progression. Yeah, so it takes really long time, and I can't see which frame is it now. So I guess it's almost done. And you see now it takes 6 GB of memory and full CPU load. If I increase it to 0.03, it probably will eat up all my memory here. Yeah. Yeah, the processor fan start working really hard because heavy calculations. Well, okay, I will stop it. I will stop it because it takes too long. Well, you can see this is frame 45, and I have a lot of particles. And if I render it now, it will look a bit different. And just wait a bit. Here it says that generating scene, so it takes a bit time to. Yeah, okay, this is the scene. So this is 0.5, this is 0.1, and this. Oh, I forgot to cache the previous one. Okay, you get the idea. All right, let's go back and change it. I will change it to 0.15. Okay. So select flip fluid object. This is particle separation. Particle radius scale. This basically defines each sphere scale, but setting this value higher will result in more volume. Yeah, okay, well, it's pretty the same result, so I can same effect, like almost changing the resolution. So if I set it really small with 0.15 and click on this play button, it's behave like this. Well, it happens because particles basically not colliding to each other. So if I increase it a bit more, probably it will play. Yeah, but you see the quality of simulation is pretty bad. And well, maybe the one or even default value is just nice, so don't touch it. Grid scale, it's scaling factor. Well, as it says, default should be good for most applications. So let's not touch this. Okay, the initial data. Here you can set the initial velocity. If I change it and play, you see that my sphere is just coming forward. Like this. And I can see it in any direction, like so. Okay, closed boundaries is for tank fluid, so the boundary is limited by this box. This is actually a fluid box, so the liquid will be simulated only inside of this box. And for example, if I take this now and let's say I turn the ground a bit, like so, so the fluid will fall down, and if I play it now, you see that fluid is just falling down. Well, this is eternal surface, so it's sliding on surface and disappearing if it comes through this box. However, I can limit this one. So let's say I do like this, or I can even decrease the size, so the simulation should go a bit faster. So make it like so, and now I have closed boundaries, and if I play now, this should stay in a box. So yeah, you see it's concentrating here, and it's not coming through. But I can open any of this, of the boundaries, so that, for example, if I want to keep the liquid on the bottom, I close the -y. If I don't want to, I just open it and the liquid will disappear. Okay. Let's go back. Let's bring ground in place. Like so. Okay. Go back to Autodesk network. And in flip fluid object, let's click on guide. This is the next stop. This is pretty similar for RBD objects, and this is the same for fire, smoke and fire. Here I can visualize different fields. So the velocity, I can see the velocity of my liquid. I can even turn off my liquid and just follow the velocity, and you see it calculates really fast. Again, because the system shouldn't draw the spheres. Okay, I can make a density, show density, viscosity, but currently I don't have these attributes. Surface, standing for actual surface, so you can preview this. And particles, well, surface is a bit more informative. So yeah, velocity, collision. All right. Let's switch from this tab to particles. Particles. Now you see better. And here in particles we have different options. So I can switch visualization type from sprites to spheres. Even if it looks almost the same, it's a bit different for graphic card. And here I have grain, which looks like this, but I have no idea what's the difference. And the particles? Well, particles are easiest one for graphic card, so and fastest. So when you do this, when you do the heavy simulation, it's probably better to use particles. And here we can visualize visualization type, direction, value, speed. Okay, here is a color ramp, which is defining the color attribute for the particles. And currently it's visualize the V, which is velocity attribute. But here I can, if I click on this triangle, I can choose any attribute I have. For example, live, and something like this. It should change the color when it gets older. And it's not doing this, which is strange. All right, and here is ID and viscosity. Well, velocity is default. Yeah. All right, the velocity. I will leave velocity. Oh, probably it's because of visualization range. So if I change it for other attributes, it will work. Okay, here we have tabs for the rest of attributes, so we can play with this. So on the surface, you can use smoke for visualization. So it can be very different. Smoke density. So like this. Well, it can be very, very different. ISO offset, so we can do like this. Invert ISO, so now it has emptiness inside. Well, I guess it can be used for some effects, some visual effects. If I render it now, I will get, I don't know what I will get. So. Well, I have liquid, so yeah, well, it's because these tabs, they're basically affecting the viewport, not the final render. Okay. And here we have all the settings for any field. So velocity, I can play with scale, smoke again. So control the quality of the field visualization. Yeah. And let's bring it back. It can be like this, so we even can see the vectors and directions in which the liquid will move. Okay. So here is a lot of different parameters, and I haven't used them really much before, but from now it looks like I will. Okay, and let's bring back particles visualization, and oops. Oh, if it happens to you this, it's basically because you're pressing W while you're on this field. So you see. And here W is for wireframe. Okay, now I have particles, bring back this to sprite. And as a sprite image, we can choose something else. I don't know if I have something. This one? No, no effect. Well, yeah, there is an effect, but it takes my image, which is black, so yeah. But you get the idea. Alright, bring it back. Okay, next up in flip fluid object is physical. It looks pretty same like in RBD objects. And here we have bounce, friction, and dynamic friction, density, and viscosity. So if I set bounce to, if I give some value to this, it will be jumpy. And now it's really hard to see because of low resolution of liquid. Okay, and now you see it's even more jumpy. So it can be used to create nice splashes, like so. So this is overkill, but still, it might be useful in some effects. I don't know, and it should look nice and render. Yeah, so we see, and basically it's possible to freeze it later. All right, so this was a bound, and I have friction. If I set it really huge number here, so you see the liquid is really sticks to the surface. While if I have a low friction, it will just okay. This is still a lot. All right. So now you see it's more splashy. Well, the problem in Houdini is that it's also hard to tell which number is big, which number is small, and many parameters is really dependent on the scene scale, not the scale of, not the measurements of the scene, like by default it stands as preferences, file options. By default, it's unit length, meter, and kilo. That's not dependent on these values, but it depends on object scale. Okay, I set friction back to 0, and dynamic friction is the friction in dynamic, which is pretty obvious. And it doesn't want us to be bigger than 1. Yep. Okay, bring it back. And density, by default, each liquid has density of 1000. But even though if it's standing at 1000 here, the flip solver, which is like a calculator for all the liquids and the simulations, it doesn't take this attribute. So let's skip it for a moment. And collision, it can be like this. And nothing happens, which is not right. Volume offset. Well, yeah, logically that it should give me a gap between the liquid and collision geometry, but it's not doing this, or maybe the resolution is too small. What if I crank it up? Yeah, now it works. So again, the value is hard to tell which is big, which is small, and you should try. That's what you should do. What should you do? All right, let's delete channel, bring it back to 0. Okay, and here is a creation frame. So if I click this, and creation frame is, and I change it to something else, let's say frame 10, so the liquid will appear in my simulation at frame 10. So we see 10, and it's here, and it simulates from this moment. It can be useful, for example, if you have a scene where you have a lot of objects and something is going on, but you want to have your liquid or fire appear at some specific moment. So in this case, the creation frame is really helpful. Okay. Now it works like this. And let's move to Flip Solver, which is basically the brain of this simulation. And here we have a few tabs. First one is Substep, and timescale is do what it basically says. So it scales the simulation factor, and you see I changed the time scale, and now everything is in slow motion. While if I increase it, it'll be really fast. It's also affecting forces because as you noticed, the behavior of the simulation has been different depending on the time scale. So, like this. The minimum substeps is basically tells how many substeps should be done minimum for calculation. It's really helpful and useful when you're doing the collision with objects. So it helps to define more details in simulation. So instead of really fast hit and disappear, it will give you nice splashes and more details. But of course, if I set to 4, it needs to calculate 4 times more steps. And substeps here, let's set it to this. So the more substeps you have, the more accurate your simulation, but the longer it will take to calculate. These parameters is really advanced. I never used them, and it's something about resolution of the fields, which is not the subject of our lecture. Okay, particle motion. Here is we have behavior tab, and we have few checkbox, which is telling us use the friction and bounce and ID attribute for each particle. So it's basically possible to take one particle from whole simulation and delete it or do something about it. And H particles, so the Houdini will know how old each particle are. Rip particles, and okay, that is basically kill the particles. Okay, and the next one is receding, which is on by default, but this can be a little problem when you do some type of simulation. So what basically receding does is, if you hold it over, it tells that if your liquid is too fast and it doesn't meet the requirement in how many particles it should be in the voxel. So in that case, Houdini will calculate some additional one, or basically extrapolating it, which is affecting the quality of liquid, and it's not really nice. And moreover, you will get more particles than you had initially. So if I have currently I have 3,903 points, and if I play my animation and receding is on, and check now, I have 5,619 points. So basically 2 times more. Well, this can be dangerous if you want to simulate some accurate liquid, or you simulating exact amount of liquid from, for example, connected bottles. And yeah, so if I turn it off and play the simulation, and I have 3,704. Huh, that's weird. Oh, sure, because looks like some of my points is already disappear. Yeah, disappear through liquid box. Yeah, because now here it's holding the same amount. Yeah, so that was receding. And here you have all the parameters to control it, how much particles it will add by default. Yeah, I never use separation and droplets, so I have no idea what it's for. And it was a flip solver. Next tab is volume motion. Here we have force scale. It can control the bounce force or smoothing of the liquid. Here is volume limits, so it's basically defined the box size, the fluid box. So if I know that my simulation shouldn't be really big, so I can decrease the fluid box, and it will help me to decrease the simulation time. So I don't need to have this fluid box to simulate the small liquid. And it's also a very important parameter because if I middle mouse click on the flip solver, I can see these numbers 36, 13, 35 and voxel count. This is the resolution of my liquid. So once I have a huge box size, I have the low resolution. If I decrease it, resolution is the same, but on smaller box. It's basically the same effect like if you have a cell phone with full HD screen, the pixel density is really high, and if you have a full HD which is 1080 on 27-inch monitor, the pixel density is different. So the image on small screen will look better, even if it's the same resolution. So collisions, here we have control about collisions. Viscosity, here we can activate our attributes, viscosity attribute and density attribute, which I showed in flip fluid in here. So if I set viscosity to something and it's activated here and I play now, my fluid will be really viscous. Like you see, it's not water anymore, but honey or something like this. And by controlling the viscosity, we can like freeze and unfreeze the liquid. So you see, after collision, my liquid become almost like a stone. Little deformation here, but now it's almost static. And if I wait a bit, okay, I will decrease the viscosity and play now. So now you see it's melting like a wax. Yeah, really nice, really very cool feature. And density is allowing us to have such effect like different density of the liquid in real life. So for example, if you take the water and benzene, they will merge, not merge, but combined. Sorry for this word. Combined initially, but then after a few hours it will split it to two parts, and benzene will go up and will go down because it has different density. So it's absolutely possible to replicate this effect in Houdini. Okay, and I will show it a bit later. All right, density, and we can use attribute. So I can create my custom attribute for this and set any value, or for example paint some attribute like I did it on distraction lecture, and use it. Solver. So here I have mass scale, so I can control the liquid mass, and now it feels like it's melting a bit faster because the mass is different. I'm not familiar with all the parameters, but at the beginning you don't really need all of them because it can be really messy and difficult to understand. But once you start working with this more and more, you'll be familiar with all of them. And distribution. The liquids in Houdini are allowed to be distributed among few machines. So if, for example, at school we have few machines which has Houdini, I can type the address of these machines and the port and basically split the simulation. I haven't tried by myself yet, but I saw people complaining in internet that there will be a little gap or visible slice between all these pieces. So you either need to have a high resolution of this liquid, or initial state of this liquid must be not optimized but offset. So you won't see this um, gap. All right, and merge and gravity, which is standard nodes. All right, so this was a liquid which I create from flip fluid, so it convert my geometry. Any geometry can be converted, and I guess it can take the animation. So if you have something animated, it can be a liquid. Alright, I delete everything and I create a new ground, just for sake of speed. Ground sphere, and this time let's click on emit particle. There's icon, the third one, emit particle fluid. I hit on this, and Houdini asked me about this blue line underneath, select fluid or fluid box. Well, currently we have no fluid box or other fluid, so I basically hit enter, and it creates a fluid box for me and liquid. And now if I play, this will constantly emit my liquid. Okay, like this. So it hit the ground, it splash. Let's see which parameters do we have here. And emitter is placed in sphere object, which is default sphere I've created before. So it was my sphere, and Houdini automatically add these nodes. And let's check the create surface volume. All right, here let's start from noise. And the thing is that when I start my animation, pay attention to the tip of the liquid. It's very even. It's not real. So if I add a bit noise like this, sorry, not correct noise, not right noise. I need to be in velocity volumes, yeah, and curl noise here. So if I add a bit noise and emit it, so you see here is my velocity lines, and the liquid is not even, but like from like in a bathroom from a crane. So it coming down, and it has different velocity, noise, and even now it behaves a bit different. So it gives more interesting, more natural result. And here is a swirl scale. So you see the velocity. I think it's possible to turn this off. Yeah. So I see just the liquid. And alright, velocity volumes, add curl noise. And here on streamers, I can see it tells which type of visualization it uses. So the smoke is nice, but not very informative, while the streamers is really nice. Okay, and here is scale, so I can control my field. And well, it's too much. Too much, but looks really nice. Like a huge explosion. Alright, I will set it to 3, for example, and play animation. So even now, liquid emits very interesting. Okay, let's bring it back to 1. And here is scale, swirl size, which is really affecting the behavior of the liquid. And attenuation is basically how the velocity attenuates. Turbulence. The more turbulent the noise, the more, well, the more turbulent. But it's also really effective for the liquid. So here is all the parameters which can be used to make a nice initial behavior for the liquid. And offset. So it's basically offset for noise. So once again, if I turn it off, it's boring. It's boring and unreal. Okay, Vortex. I can create a vortex for the liquid. And let's turn off noise to see it better. Oh, it's center. Excuse me. I need to increase angular velocity. And you see that velocity of this liquid is become like a cylinder. Well, probably this is too much. So let's play now. Okay. And you see that spinning force is just moving liquid from the center of the emission. So also really nice effect. And here I have limit vortex, which can control how it behaves. So like this. Vortex radius, I guess I need to change it. Yeah, like this. And now force is working different. So you see, when I'm changing the ramp, how it works. All these parameters are really nice and allowing to create very unique look and behavior for the liquid. Okay, this is Vortex, and the object add object motion is for tracking. I guess it's for tracking floating object or something like this. Okay, so I turn off Vortex, and I can add the velocity here again. So now it goes like this, like under pressure, and give some Vortex, so it turns, and a bit of Carl noise. So yeah, it's spinning and it's noisy. Looks really nice. And once you have the high resolution for the liquid, it will look really awesome. So let's render this and see how it looks. And this is default water shader in Houdini, so it's for many situations it's fine. And we'll talk about shaders in a few lectures and rendering and lighting. And basically I calculate that it's around 6 to 7 lectures left. So we need to talk about fire and cloth, maybe about fur, and ocean effects, well, and rendering, lighting, and shaders. Okay, so looks pretty awesome. Alright, go back. So this was an volume emitter. Okay, let's go back, delete everything again. Oh, wait a second. Yeah, I forgot to tell. Here, in previous example, we had only a flip-lit object and flip solver. Now I have source surface from my object. And if I select this, I have initialize type, so it's a source flip, volume path, and activation. Activation is pretty nice because it tells to use to flip solver when to activate this liquid or when to stop emit this liquid. Okay, so now it's playing like this. I'll decrease the resolution a bit just to make it faster. Okay, like this. Alright, and let's say I want to... Oh, I crashed. Crash. Don't forget to save. And when you're crashing, Houdini save the scene into your folder, temp folder, and you can say you can find it later and basically open it from here. But I'll create a new scene, fresh new scene. Okay, the ground, the sphere, emit, hit enter. So alright, I have this liquid. Liquid, decrease resolution. So let's say I want to stop emit this liquid on frame 30 here. To do this, I'm going back to source, and in activation I type $f smaller than 30. So this expression will be true while will be 1 while my current frame is smaller than 30. Okay, and now I play it. 28, 29, 30, and there is no liquid. Well, it goes like this here. On frame 32, it looks like there's still emitting liquid. No, it's the rest of the liquid coming from this volume. So there is basically no liquid after frame 30. Okay, and if I want to start this after frame 35, or let's say 50, I type logical and I just need to find it on this keyboard because I have the region 1, and it's always a trick. Alright, let's logical and I need the sign. Oh, come on. So it's 2 vertical lines and dollar $FF bigger than 50. So now it will play and emit liquid until frame 30, then no liquid, and on frame 50 I got a fresh liquid. And you see it's already, the simulation is already really slow because of a lot of particles. Even though my resolution of the liquid is kind of slow, because the high resolution is around 600 or something. So to make something useful in Houdini, you have to have at least 24, 32 gigs of memory. Under this value, you hardly will get something useful, or you will wait forever. Okay, so this was an emitter, and here is different stuff, which is, we're not gonna talk about this now. All right, I create everything. I'll create a new scene just in case, and sphere. Oh no, I don't need the sphere. Let's create the ground. And on particle fluids, there is a second button called flip tank. I hit on this, control click, and it will create it in the center of the world. And here I have my fluid box. And I did a mistake because for fluid box I don't need the ground. So I need to delete this ground object and remove it from dot network. So what is the flip tank? It creates invisible box around this fluid, and this fluid will stay always inside of this box. So yeah, all right. And to get the parameters of this fluid tank, we need to go into object level and fluid tank fluid, and oh no, we need to go to fluid tank initial. My fault. Okay, fluid tank initial, and here we have fluid tank. And particle separations here, please don't touch it because it's connected to Autodop network. So once you change it in Autodop network, it will automatically take the value from here and bring from Autodop and bring it into this node. Okay, water level. By this slider, I can control how much water I have in my box, like this. And here is obviously the size, like so. I can change it. Center is translating the whole fluid box. So, like this. Right? And the up axis, I can change it to X, for example. So let's decrease amount of water. So my ground is like in normal position, but my liquid is on the right side, in the bottom of X. So if I play the animation now, the whole liquid will fall down, like so, and will create the nice wave, like this. And once the resolution of the liquid is kind of small, there is not many effects, no splashes, no nothing. But you get the idea. I can change it to Z axis, and it disappears because my liquid is somewhere. Okay, I found it. And it's basically the same as in previous, but on different axes. Okay. Let's bring it back to default one, which is Y. And here we have viscosity and density. So again, if I activate it here, and then I activate it in Autodop, on this place, I need to click on viscosity by attribute. So in that case, the solver will take the attribute of this fluid and calculate it. And you need to switch to multiply, and viscosity scale, let's leave it in default value for a moment. And what it allows to do is it allows to take a few different liquids and give them different viscosity. All right. Um, for test purposes, I will do like this. So now I have the viscosity, and you see that liquid is not the water anymore. It's more viscous, and it's moving, not like previously. So if I increase the viscosity here to 100 and play the animation, it will be almost like a glue. Or maybe I need to have more viscosity. Okay, and what if I change it here? Okay, it happens sometimes, and the workaround is in flip solver. While you have this activated, you need to select the flip tank, and in physical set the viscosity into very small value. So 1 in -10. Okay, and now it should help. All right, if this doesn't help, there is another workaround. Is on particle fluid we have make viscous button. So I click on this and it asks me select flip objects to make viscous. So I select my flip tank in Autodub, put my mouse over viewport and hit enter. Okay, so if I play it now, yeah, you see it works. Sometimes you have to do this, sometimes you don't, but in that case, well, in case of fluid tank, you need to do it, but on different liquids it works. I don't know why, it's just how it is. So you see now it's like melting butter or something. Yep. So let's decrease this. Too much. So the viscosity scale here, if you have a mixed method multiply, is, for example, if I have one liquid which viscosity is 1 and second liquid which viscosity is 10,000, so the scale will multiply initial viscosity to this value. And scale 1 will do nothing about viscosities and it will use default values for the liquids. Okay, let's decrease it here. So you see now it's liquidish again. Yep. All right, and this was this three type of liquids. Now I want to show you density and viscosity, how it works in real life. So I delete everything. I create two spheres like this, and let's place them on the same height. Just I'll set it on in one direction. So I have two spheres, and let's create the ground like so. Now I need to create two liquids, but the thing is that if I create liquids just by selecting one sphere, click, second sphere, click, it will create two separate liquids, which will not collide between to each other. To make them collide, I need to excuse me. I need to create a sphere, select the sphere, and emit particle, and hit enter. So this will create the fluid for sphere 1. Okay, and let's decrease the resolution so it calculates faster. So this is liquid 1. Now I'm coming back to object level, select the second sphere, and hit on emit particle. And again, it asks me about create a fluid box or select the current one. Yeah, okay, now I need to go to Autodop network, and here I need to select this flip fluid object. Then move your cursor back to viewport and hit enter. This will create a second liquid, but if I check my Autodop network, I see that I have two sources, which is merged, and then going to flip solver. Okay, it was an accidental break. So after two sources going to flip solver, they will calculate and collide together to each other. So let's play the simulation. So you see that liquids are colliding, but currently they behave absolutely the same because their parameters are equal. And now let's change the viscosity of this liquid. I will first go to sources, and let's say the left one will be viscosity will be 0.1, and second viscosity will be around let's say 1000. Okay, now let's go back to Autodop network, and in Flip Solver volume motion, let's activate viscosity, and viscosity by attribute mix method, it's necessary to switch to multiply, and viscosity scale 1. Okay, let's try to play it. And behavior is the same. Well, let's click on this button, so select nothing, click on May Viscos, and now select the flip fluid object, and hit enter. Okay, let's play now. Alright, now viscosity works. It works, but currently, well, I can see that they behave different. So in flip fluid object, I will set viscosity to something really small, like this, or maybe even smaller, like so, and play animation now. Alright, so now all of them are not really viscous, and multiply 100. Cool. Now you can see that left liquid is really fluidish, and the right one is really viscous and behave as a honey or something like this. So if I increase the scale, this effect will be even more visible. So, like this. Also, to make it more visible, I can make to make liquids more visible, I can create the color node and give some specific color. Let's make this green. Let's make this red. And if I play animation now, alright, I can see that how each liquid behaves. Oops. So, like this. The right liquid is a bit too dark, I guess it's because of light. So if I drop light here, and increase the intensity, well, okay, now it's not because of light. And maybe it's if I change the in guides, in particle visualization to grain, spheres, particles. Well, okay, it works in particles. But in rendering, at rendering, this will have the same colors. Just different behavior. Okay. Oops. Stop. Okay, this was example with viscosity. Now let's see how the density behaves. So I delete everything again, and we'll create the flip tank again. Let's make it a bit bigger, like this, a bit less water. Alright, and now let's create the sphere as an emitter and emit particle from this. And again, these two liquids should be able to collide to each other. And to make this, I need to go to Substeps network, and here I need to select a flip tank, move the mouse over viewport and hit enter. Okay, so it creates the network for me. So I have my source surface from sphere and my flip tank. If I play the animation now, let's change the resolution. If I play the simulation, I can see that my liquids are colliding. And now level of the fluid in tank is increasing. So I basically can fill up the whole tank. Okay, now I change guides from sprites to particles, so I can see my liquid. So when it's falling down, I can see all my liquid, and now it's coming through the whole liquid and replacing it in the bottom. Okay, now I will create the color again. I will add color just to make it more noticeable. And let's say red. Or maybe black. Yeah, black will work fine. So I can see how my liquid comes through like this and replaces the default liquid. Now let's create a density attribute for each liquid. To do this, I need to go to flip tank initial and create a density. So let's say this liquid will be first really light, so the density will be really small. And the sphere object will emit really dense liquid. So I go into sphere object, select the create surface volume emitter, and in particles tab here on top, I need to click on checkbox, on density checkbox, and set it, for example, 1000, like this. Fine. But again, I need to go to Substeps network, and in flip solver, in volume motion tab, I need to go to density and hit this checkbox. Okay, and the mix method is multiply again. Let's play the simulation. I will decrease the resolution one more time, like so. So now you see that behavior is more turbulent, and the black liquid is coming down and just pushing the blue liquid higher and higher. So if I stop it and will change my visualization to spheres, you can see that the black liquid is underneath, like so. Well, let's go back to particles. Alright, and Now let's do opposite thing. So the fluid tank will be really dense. Let's say this 1000, and the sphere object is 1000 also. So now I'm playing the simulation, and liquid, since it's the same density, it's not really messing up. Okay, it still replaces, but again, it's really different. Alright, now let's change the sphere density to 0.1, like this. And let's play the animation. Now you see that black liquid is going this deep, and it's basically staying on top of the blue liquid, and it's really splashy. So once you have different shader for these liquids, you can create a different effect. Okay, so look at this, really cool. If I switch my visualization from particles to surface, well, yeah, it's not really it's not visible because liquids are, the visualization is the same. But in this case, I can see very clear. Let's change the color. So yeah, that's how it behaves. So the liquids stay on top. Okay, these two attributes is really essential to make something nice in terms of simulation. Okay, let's delete everything again, and now I need to create a flip tank. This one more time. Again, increase this a bit, make it a bit taller, less liquid, so it calculates faster. And now I will create my emitter. So here is my emitter, emit liquid. Again, to select this liquid, I go to Autodesk Network, flip tank, hit enter. So let's check, and my liquids works, so they are colliding. And now let's create the, let's say, box, and scale it a bit, something like this. So theme box, this will be a collision object, something like this. Well, the form doesn't matter. And now I need to convert this object into dynamic object. So I select my box object in the node editor and go into rigid bodies tab and hit static object, like this. So now my fluid will come down, hit this surface, and go into the water. And let's check. Well, again, the fluid resolution is really high, really small, so I can't really see how it behaves. But if I make it smaller, in the flip tank, let's say 0.1, and let's check our collision geometry. And here, well, this is really high res, so I can decrease resolution, and this will calculate a bit faster. So turn this off and let's play now. So you see the calculation is really slow, but I will get more details in splashes. And you can see that there is penetration of the particles. To avoid this, I need to increase substeps. But again, since I have a really small um, particle separation, so I have a lot of particles, and if I increase the substeps, let's say 4, it will take even longer to calculate. But this should solve the problem of penetration. So that's the reason why you may want to increase the substeps. Well, it's still penetrating. Okay, let's turn the box resolution back, or even increase to 60. So now it looks like this. The collision must be really accurate. Wait a minute. Well, it's still colliding, but you see the penetration is way smaller here, because previously it was going up to here. So by increasing the substeps and rising up the resolution, because now it's very low. It's very, very low. I can solve the problem of penetration. So like this. And you see now it's way higher. But again, the calculation is slow because we constantly emit a lot of fluid. I guess it's possible to decrease this amount, like by changing the size of the emitter, or by going to source and scale source volume, make it smaller, and now emit. Well, it looks like the flow is a bit smaller. Okay, let's increase this. Okay, scale source volume, make it even smaller. Well, okay, looks like you need to change the source size. Well, now you see that water is colliding with geometry, and the object is an active object. And if I render, I can see that this is my liquid, and the geometry is here. Well, now the resolution is 0.2 and there is no splashes at all. So it feels like a jello or something like this. And it might be useful. So for example, if you're simulating the jello and you want to have really high viscosity, so in that case, no reason to make a huge particle separation and waste resources, because anyway your liquid will stay like this. So you can increase the particle separation and calculate faster. So you see, it's not a huge difference. So this was liquid, and here is few more buttons. I will probably talk about them if I will have time, because I need to cover up more themes. But in case I have time, I will talk about mists, which is create little like water particles coming from waves, and white water, which is also a nice effect. Okay, so thank you for watching, and it was a lecture about water. So bye.